Hi, Math Doc back here again with another video on linear functions. And in this, the next set of a few videos, we will review the different ways, the different forms of presenting linear functions. So we're going to start with the function notation, right here, function notation, which looks like f of x. So we for a linear function, we're looking at something like f of x equals 2 times x plus 3, for instance, as an example. But basically, this is the function notation, and we'll see how we use the function notation to graph linear functions. So if you haven't seen the other videos on linear functions, check a look at that at the playlist. And let's get right to it. So the function notation of a linear function, f of x here, it's really similar to the way we define it with an input of x and an output of y, right? So we could write it this way, where y is basically the same of f of x. The reason we use the function notation is because we can have situations where we have more than just one function. And in that case, instead of using just y, we can use different letters to denote the function. And when we have these parentheses with an x inside, like here, what we're actually emphasizing is that our variable is x, and our function f of x is dependent on x. So our function f is the dependent part, right? While x here is our independent variable. And in all the problems we look at, in all the word problems, it is important always to identify what is the dependent variable and what is the independent variable. The dependent variable is a function of the independent variable. So let's get to our example here that'll help show us how to graph using the functional notation. We used this example before, the gym membership cost, and we're looking at a cost that is composed of a registration fee, which is a one-time fee, so it's just a number, and a monthly fee that depends on the number of months, x, right? X is the number of months, so it'll depend on the number of months we purchase membership for. So we can have different forms for this function, even if it's a linear function. And in the different colors here, I've included 3 different types of membership. We have the basic membership here in red, where a person pays $25 to register and then $30 every month. That is the monthly payment. And so our function here is b of x, not f of x, but b of x. Traditionally, we use the f because f stands for function, but we can use any letter, especially if we're looking at more than one function, right? So here we have b of x for the basic membership, and we usually use a lowercase letter for a function, but that is not an absolute rule. We also have the weekday only membership here in green. Weekdays meaning that when we get that membership, we pay only for the ability to access the gym during the week and not on the weekends when it is especially busy. So in that case, we're paying actually per month half of what we pay for a basic membership. So we have the same registration fee of $25, but monthly we only pay $15, and we call that function w of x because of the notation for weekdays. We finally have a slightly more expensive membership, which includes the gym and the pool. In that case, again, we pay $25 to register, and we pay monthly $40 because we also use the pool. So you see here we have the same registration fee, but our monthly fee is what changes. Our independent variable x here is the number of months, so independent variable. And the pool membership is denoted by P of X for pool. So let's graph these different functions. We have here X, which is the number of months, and Y here, our Y direction, is going to be our membership cost. And we have different types of membership, so we will use the different colors. So starting with the basic membership, if we use the membership for 0 months, we'll just have to pay for our monthly fee, which is $25, right? Right there. Now, if when we want to, let's put in 1 month, 2 months, and 3 months. Okay, so if we pay for a single month, we pay 55, right? So let's put that up here, 55, and we can put our dot there. And for 2 months, we pay $60 for the monthly fee, right? 30 times 2 plus 25, that's 85. So let's go up here to 85. Okay, so these are 3 points. We'll start with that for our basic membership. And you can see that we could pass a line through these 3 points. However, this is a discrete function because we don't pay for half a month or any other fraction. We only pay each month. So we will not put a line through this the points on this graph. So what happens with our weekly or our weekday only membership? So for the first month, for the 0 months, X is 0, and so we're still paying just 25, right? So we'll put another dot there. Actually, maybe we'll make X's for our green. Now, if we pay for 1 month, we're looking at 15, right, times 1 plus 25. That's just 40. Let's say 40 is about here. So for 1 month, we're here. For 2 months, we're paying for 30 plus 25. So that's exactly 55, similar to this one. And for 3 months, we're paying 45 plus 25, right? 3 times 15 is 45, plus 25 is just 70. So let's put that over here. So this is our second linear function. Okay, and our third linear function is the one that actually grows the fastest because that one has a higher monthly fee of $40. So again, down for 0 months, we're just going to pay the registration fee, which is 25. For 1 month, we'll pay 65, so we'll put that up there. For 2 months, we're going to pay 105, so we're already up here, and so on. Now, we can put through a line just to see how these different functions are behaving. I'm going to do that in a third color, just so it's clear that it's not actually the function. So our red membership here, let's see, let's make that a thicker line. Our red membership is going to go like that. Our green membership like that. And our blue membership like that. So we've graphed all 3 memberships and we see that they have different slopes. But the idea is that when we graph a linear function using the function notation, what we're doing is we're evaluating the function. So we've used these functions to evaluate at every point what the value of the function is for these different x's. If we were to go on to month number 4, we would evaluate the value of these 3 functions when x equals 4. So that's how we graph a function that is given by the function notation, and we will be practicing more. But in the next few videos, we'll look at the other forms of linear functions so we get a good grasp of those as well. So thanks for joining me. If this was a helpful video, please like. Please check out the other videos on linear functions to get a better background, and I'll see you next time.